Good morning. Thank you for joining us today. We are very excited to host Neil Manvar of Yahoo Mail as he talks about how he helped transform internet giant Yahoo Mail's quality engineering process through functional testing and continuous delivery. Neil has been a front-end developer for Yahoo Mail for the past 2 years. An open source enthusiast, Neil helped develop a functional testing framework at Yahoo on open source technologies like Water, Cucumber, and Sauce Labs, which replaced an in-house developed solution that was hard to maintain. I look forward to hearing what Neil can share about this transformation. Before we get started, I wanted to go over a few housekeeping items. This webinar is scheduled for 60 minutes, and we will save time at the end for some Q&A. To ask a question at any time during this presentation, please do so in the Q&A box within your WebEx panel. We will be looking at those questions throughout Neil's presentation, and we'll address those at the end. Additionally, please note that we are recording this session and we'll send that out to everybody that has registered within about a day or two after the presentation is finished. With that, we're going to go ahead and get started and send this over to Neil. Thanks, Neil. If you were muted, you are unmuted now. Neil, I think you might still be muted on your end. I unmuted you on the WebEx, but you might have muted your own computer. Please bear with us. Just give us a minute to get Neil back onto the line. Hi, I just spoke to Neil. He is going to be joining us in just a second. Please bear with us. Neil.
Oh, cool. Live now?
Hear you.
Got it. Hello, guys. Neil Manvar. I'm a front-end developer at Yahoo, and I work on Yahoo Mail. Been there for about 2.5 years, almost 3. Before that, some history. I was an intern at Yahoo for 2 summers, so 2 years. And I was in the QA department and for both those internships. And after the second internship, going into my job, I switched into front-end development. I'll go into that story a little bit later as well. Things I wanted to talk about today was what role functional testing plays at Yahoo and how it integrates into our pipeline, and how we do continuous delivery at Yahoo, and also what will enters PMs and everyone else has in that. So that being, I'm going to go on with the presentation. and a Q&A at the end of it, so save your questions. A little bit about me. Like I said, I've been with Yahoo Mail for more than 2 years. I did computer science and engineering at UC Davis. I got my grad in that. Few of these include UFC, MMA. I'm one of the very few computer scientists into violent sports like UFC and MMA. But while that, I do enjoy a lot of bicycling. I cycle every day to work and on the weekends, and I do play a lot of video games. Some of my interests inside the field include functional testing and exploring new front-end technologies. So I'll explain our tech stack at Yahoo, but some things I'm looking into now aside from our tech stack are Protractor, Zombie Driver, and some other stuff I'm looking at is React. I'm trying to learn a little bit of that. I'll try to use a little bit at Yahoo. So stuff changed at Yahoo Mail over the last, I'd say, 3 years. Before we used to have a model where developers would write the source code or write a feature, and then after the feature was done, the QA would take over and certify against that. The developers write the source code. Hopefully they've written some unit testing. Before, actually, we enforced no unit testing coverage, and we had very little. So the problem was after when the feature needed to go and the QAs were testing, they would find bugs, and this process needed to repeat itself over and over again until the feature was completely done, and there were bugs. And anytime anything new was done to the feature, the QAs would have to test the existing set of features, plus the that would iterate many times as new features were introduced. So basically, we were getting bottlenecked by the QA. And new browsers come out, and new operating systems and new devices, you need to test against all of those. So the problem becomes even more and more complex. For instance, if do an example, if we made a new search feature in Yahoo Mail, we would make sure that it works for all versions, 8 or 9 and above. We have a separate product for IE8, but IE9 and 11, and then all the Firefoxes, all the Chrome, and any Safari, and back in Windows 7 and Windows 8. So it says we need to make sure that Mail works on various configurations, and our web app became more rich with features. We started seeing more regressions. Just like I said, we became bottlenecked because QAs couldn't test everything, and the developers were just keep writing more and more features, and product managers just keep giving more tasks to developers. I really realized things needed to change when we would push something, and then a couple later we would hear back that the graphs were spiking, errors were spiking, speeding up, and we'd need to revert back the code and basically start over again. And management finally decided that something to happen that we call change-related outages, that we have no related outages. Any outage that we have is because of source code or something that went wrong in the system, not because of change that needs to go out. So our company started to make a strive towards achieving continuous delivery, which is the CDD model. For those that are a little unfamiliar, continuous delivery is defined every commit should go to production, and commit should go to production unintervened, meaning there's no manual intervention. When a developer commits something to GitHub or to Git, it should automatically, in some time frame, production and to the users. I'll explain what this achieves in this as well. So it's management and tech that decided that to go to the CD model. So what happened is Yahoo Mail got put into a mode where we're going to slow down on feature development and allocate some of our engineers to the pipeline and try to achieve the CD model. So back to what a CD model would achieve. Model in a couple of minutes. I'm going to talk about our tech stack a little bit, our functional testing stack, then I'll come back to C and how the functional testing and CD come together. So we use once I got my job at Yahoo, manager told me we used to have this old framework that was managed by a team that kind of forced you to Eclipse. It was in Java and heavy weight. There was a lot of unnecessary logic, and it was very hard to maintain as well. When new browsers came out or stuff or interchanged, the framework would not adapt very easily. And developers weren't writing, developers, even QA engineers weren't really writing tests in that because in an enjoyable way. You were forced into this heavyweight thing, and you had one way of doing things, and very slow too. And it didn't achieve as much parallelism as we'd like. So my manager gave me this task and said, hey, we need to make writing tests enjoyable. That way we can get everyone to write tests, and we can increase our test coverage. Because if it's not enjoyable and it's not maintainable, then it basically isn't. A lot of that I've seen at some companies where sometimes since writing functional tests is not enjoyable, people actually do manual testing, and QA engineers and QA departments continue to do manual testing. But like I said, the problem with that is if you tested something, if you did a feature before, you have to test that same thing again. That's what the automated tests are the best for. Once you have an automated test in place, always ensure that that feature will never be broken. But if you are depending on QA engineers to certify your product, they might forget to test that feature and certify it anyways, and which could be a problem where code is broken in production and there are revenue impacts and whatnot. So back to the testing framework, we call it YQ. So my manager told me to make something that's enjoyable for everyone to write tests. So I explored some various technologies, just running the test, so runner and test writer. So I established that Cucumber was our best choice. Cucumber is a BDD tool that lets you write things in Gherkin, which is kind of a natural English language, and it maps each line of has a step definition into a step definition, which is a regex that defines some action. I'll give you an example of a Cucumber test case, or more like a YQ test case, Yahoo context. So we use Cucumber for writing our test cases in kind of plain English, so that's very readable and very maintainable. Having a case in kind of this plain English format is that when thing breaks, you can see where it broke. For instance, given I logged in with user 1 and I click compose, then I should see the compose tab. If it breaks then I should see the compose tab step. You know that clicking compose didn't launch the compose tab or the RT. So advantage of Cucumber, where you can kind of just without digging into code, you can know what went wrong or what's happening. And also, it really helps in that management and PMs can see what test cases we have. Before, when we were using a cell NG, management and had no idea what the test cases were doing or how much coverage or any of that, because it was written in a pure Java. But then some of it's written in since some of it's written in English, they can contribute sometimes, or even engage the quality of cases and see what we're testing for. As a WebDriver, I chose Water WebDriver. WebDriver is a wrapper around Selenium in Ruby, and all this does is make writing acting with elements much easier. Whereas, so one comparison I do pretty frequently, in WebDriver, you would say browse.find element by ID, then you give the ID, and then you wait for present, and then you click it. Probably like two statements. In WebDriver, you can say browser.element, then colon ID, the ID element dot when present click. So it's kind of more concise, and it eventually translates into Selenium. It just makes writing and interacting with elements easier. And then third, there's the page object model. We use page object to represent various parts of the page, and to abstract that out. So basically, the test should not bound to the test elements. The test elements and the selectors to those test elements should be in the page object. Now, an example I could give of this would be like, for instance, the left rail in Yahoo Mail consists of inbox, drafts, trash, spam, and some other things. That would be page object. Be the left rail page object, and then each one inside there could be an item. Some other things we use page objects for would be each message list is a page object, and in the bigger scheme, we have a message list page object, which consists of many messages. So you want to keep the selectors and the information about your app in the page object, and the feature file of the Cucumber and the step definitions. The feature file should call step definitions, and the step definitions should interact with the page object. So the definition and the feature file should contain no information about the app being tested or the Selenium unit. Fourthly, we use a parallel test to parallelize test execution at build time. So how we leverage parallel tests is each scenario. A test case is a scenario is a test case in Cucumber. Each scenario will get divided into 6 scenarios, actually. And for example, if we have a compose test case, just let's verify compose opens. That test case will get divided into 3 test cases, or 6 test cases, to represent 3 browsers and 2 different languages. So we execute each test in 3 different browsers, which is IE10, Chrome, and Firefox on Windows 7, and in English and in Hindi. So if a test suite of 200 tests, we'll execute 1,200 of that time stick, which is, again, the 3 browsers and the 2 intels. And but I would say it's Sauce Labs. Without Sauce Labs, almost none of this would have been possible. We need somewhere to run our tests. And I'll end the before versus after for this too. But Sauce allows us to throw about 100 to 300 tests in parallel and get them all executed in parallel, and lets us get our results back 10 times as fast. we had this internal system where we were only had a certain number of VMs and a certain number of VMs of particular types. For instance, only, let's say, like 100 IE10 VMs and only 200 Chrome Windows 7. And this was shared all amongst the company. And since we really wanted to do tests in parallel and get our results as fast as possible, our internal our tool wasn't able to support this at the time. And because when we threw 200 tests at it, not them would get executed, or we'd have some stability issues, and there were enough VMs available. So in that, we decided to pilot Sauce Labs, and it worked out really well. Started out with 50 VMs, then moved on to like 100, 150, 300. Now we're about to go to 600, and this allows us to execute 600 tests in parallel in all the different browser configurations that I explained, browser and language combination. So that's our testing stack. Any questions? Just well, we can talk about it at the end. Okay, on to a sample test case. Here there's a test case for composing a new message, and it says I'm saving it as draft. So I'm going to do it, and then I'll kind of explain each line. Given I'm logged in Yahoo Mail as user 1 and composed, and at the subject field with some random content, and I fill out the email body with some body content, and by pressing Control S. Then I see the save draft confirmation notification. So logging in, opening Compose, filling the field with something, filling out the body with something, and then trying to save the draft using the shortcut, the Control S shortcut, and verifying that some type of draft information, draft save confirmation notice is present. All of our test cases start with a given, so you kind of have a base to start off with. If I'm testing Yahoo Mail, I want each test case to start off with the launch of Yahoo Mail. So given I am logged into Yahoo Mail as user 1, what it does is make sure that I have Yahoo Mail loaded as user 1. So it authenticates as user 1 and then goes to the specified base URL that I'm testing as mail.yahoo.com or whatever internal server that is for us. And then on Compose, and it'll click the subject field, then it'll fill out the subject field and the email message with some content, and then Control S. So now we'll go on to the step definition, and I believe I'm going to take one of these. It'll be the fill out subject field. So the fill subject field definition was located in Compose steps.rb, and this contains all the step definitions you can deal with the Compose page. So we wrote regex for, and I fill out the subject field with quotation wildcard content. So, and I fill out the subject field with some random content. What we do is this on-page compose do page will load up the page object, which is this page. Then page.subject field will access the subject field. And then when present, it waits for it to exist on the DOM and be visible. And when it exists and it's visible, it sets the content, or its subject field with the content that was provided in the regex, which was some random subject, some random content. So when the page object is loaded into the variable page, and then we access the subject field, we WebDriver when present to wait until it's present, return the element, and then we set the content of it. And I'm going to move on to the page object for compose page. So basically, I showed you a feature file, looked at one step definition, and that step definition accessed the page object and interacted with it. And now I'll show you the page object itself. So, compose page object, what we do is we make a class, and you include the page object library, and you then make a method for the subject field. And the field is a text field, meaning an input of type text with ID to field. Pretty simple. Some complications we have in this model is parallelism, meaning that when we run all our test cases in parallel, it sounds a little easier than done. Runs into a lot of account problems. For instance, if we had a test case that deleted and verified that the email was deleted, that test case looked for some other message and deleted it, and there's 6 instances of this test case happening in parallel. So there's no knowing when that message is in the trash or it's in the inbox. So basically, whenever you're doing any actions to any email or any email at your mailbox, there you could have account problems. So delete test case is one that we see this with. Moving a message is one that we see this with. Basically, that deals with a particular account state, it can present a problem when executing in parallel. And the way to solve this is we try to inject the appropriate information into the inbox, into the mailbox before the test case. So, example, if we were deleting an email, what we do, we try to, before the test case starts, we try to have email already in the inbox that's ready to delete. So every time this test case launches, the mailbox launches with one test case or with one email message in the inbox. But I can imagine there's all sorts of different account problems and all varying degrees. Account problem we deal with often is when we're testing conversations mode. Conversations mode is threading, meaning that your emails are grouped together into a thread. And if you're testing that, you have to toggle it on and off to test against it. But since that test case is executing into 6 different threads, I don't know whether when that feature gets flipped on and off, and it could affect a different instance of that test case. And the second problem we have is abuse/anti-spam. So with a big company like Yahoo, where there's been a lot of abuse also and spam coming through, when the test cases run, it actually sometimes thinks of it as abuse. For instance, if you have a message that sends if you have a case that sends an email, and test case goes and account is that account's mailbox, or that account is logged in on 6 different machines and sending an email message, our systems catch that as abuse or as spam and will lock that account for an hour. So we deal with that. The way we deal with that is we put our users into a certain farm that has a lenient threshold, and we're also going to this new solution where we're going to authenticate and use a feature flag of some sort to turn off the abuse for these internal test accounts. Anti-spam sometimes gets in the way. You're doing your job and they're doing their job, but the iffy gray area where we have to define that these are our tests, please don't block them. on something like that. So those are the biggest problems we have with parallelism, which are the count problems and the abuse and anti-spam. So now a little bit back to continuous delivery. I define continuous delivery as every commit should go to production unintervened or manual intervention. So the advantage of this is when a developer commits some piece of code, at any point it could go into production. So if he did not write appropriate tests, then broken feature could go into production. For example, I'm going to go back to the search box. If the developer writes a new search box and it works perfectly fine, but there's some problem where if you search box and you enter nothing and you press enter, it'll break mail, and he doesn't write an automated test case for that, then his code will go to production if there's no existing test case for pressing enter in the search box. He or she must write a test for that. So what delivery kind of enforces is that the developers have to write the test cases. They wrote the source code, so they have to write the unit and functional tests because they're most familiar with that code or product. The change that the burst after of with engineers that certified and then management pushed for CD pipeline. So what kind of happened is we needed our developers to write test cases, and so we slowly our QA department until it was eventually we didn't have a QA department, and all we had was developers. And the curve in teaching the developers to write in the test. But once developers are smart people, and once they understood and how easy and how enjoyable it was to run tests, it wasn't a problem. But there was definitely a learning curve. What the continuous delivery pipeline does is it keeps the developers accountable rather than the QA, which in return will basically result in a fast-moving product. A lot of your code is pushed to production very frequently, and you have, and if you have the amount of tests, you know that you didn't break any feature. So all that comes down to having the right amount of tests and the right amount of confidence. And once you achieve that, and you keep the culture alive of writing tests for your features, and the developers, when they're done something, they have to write tests for it if they want it to go. If they don't want to break production, then it works pretty well. So I'm gonna define our continuous delivery pipeline to you guys and work we're doing on it. So a developer submits a pull request. He writes a new feature, submits a request. As part of this pull request, it should have the source code for the feature file, but it should have the test for that and the functional test. And once a pull request is filed, the unit tests are run against that pull request, meaning the current unit test and the new ones that he wrote. And we'll do a code review and merge it in, and that is only if the pull request build passes. For example, if the pull request passes all the unit tests. And after that, functional test, the unit, once again, but because, so the unit and functional tests are run, and then functional tests succeed, code is pushed to a test server, and this process keeps iterating 3 or 4 times until we get to production. Just to repeat, a developer will submit a pull request. unit tests will be run against that pull request. The pull request consists of source code, unit test code, and functional test code. The code is merged in, and then the functions are eventually run, and if the functional test pass, it will get pushed to a test server. So this process, or the functional testing process, will iterate, and then they'll push to, after the testing, it'll push to eventually our input users, meaning our internal mailboxes, our core mail, email that we use at work. After some time, if there aren't any standing bugs reported on the work mail by our internal users, it will automatically get pushed to production some amount of time later. In between all these, from test to pilot, which is internal, to 1% of users to 100% of users, we run these integration tests, which consist of various tests from different repos that make up Mail or Yahoo Mail. A little bit more about how continuous delivery keeps accountability is to write the test to protect yourself from failure. Your code will get pushed out, and you will be hearing back. And only one accountable for that would have been the person who feature. That is the point of continuous delivery. Whereas previously we were getting bottlenecked on the QA engineers and them certifying our code, whether we're writing automated tests or doing manual. We only have one way of certifying, which is the functional test that gets run as part of the build. That is no manual intervention of someone saying, hey, the code is good, so we can push it to production. It will automatically get pushed. And automatically is dependent on the thing of the functional test. The can protect you is the writing of tests. And what this enforces, developers will go crazy writing tests because they don't want to be responsible for an outage. Key is accountability, kind of. We're trying to run functional pull requests as well. There's some complications that are happening there. I'll explain those to you as well. But we're trying to do it on pull requests is because what if requests get merged into master and some feature breaks, and a lot of people have kind of touched this around a similar space. It's hard to isolate to a part of the commit what broke a certain feature. So part of that, we're trying to run a subset of functional tests on each pull request. Here is, I already said that even one build that gets run, or one test case gets run as fixed in parallel, gets flagged as abusive. So if you have 20 pull requests to run those tests in the cell, and you're going to get flagged as abuse much, much faster because the test is linked to a particular account. And if that test is executed on each pull request, then we're going to see a lot of requests coming from that account, and it will be marked as abuse. So the solution that we have proposed and we're working on right now is we're kind of mocking XHR calls. That even that there's notes going out to our backend systems from user. We have mocked the response, and so when the browser sends a response, we just give it the mock response, and it will basically only cut the front end of Yahoo Mail, which is what we work on, the Yahoo Mail front end. So basically, we isolated the back end, then we're only testing the front end. We had some interest, write a little record and replay thing, where if you test against a dev box and you can mode equal record, it'll record these fixtures that have the mock backend responses. And if we run the test with mode equal replay, those these fixtures and return the mock backend responses rather than go out to the middle gear and back end and fetch these responses. Basically done. I'm going to open it up to Q&A. Kind of went a little bit longer than I anticipated, but still leaves us 18 minutes or so for questions. Christina?
I'm here. Neil, that was really great. We did get a really good questions. So I will go through as many as we can. We have 15 minutes, so I think we should be able to get through quite a few. So I'm just going to go ahead and jump in from the beginning of the questions that started to come in. So have addressed this, you can just maybe reiterate very quickly kind of what you talked about. So the question is, how do you integrate end-to-end testing into the CD model? Because there are changes at the front end that might impact functionality at the far back end.
Oh. Back-end change needs to happen. They have to tell front and they need to stage it to some sort of an environment where we can test against it. But that doesn't change very often, and when it does change, it involves sometimes quite a bit of front end. So when we spec out the back end, don't expect it to change, and we have to keep both the systems independent. If they're dependent, then at that point we could have an outage, like you said, in a continuous delivery world. And the way that end-to-end plays a role in our continuous delivery pipeline is our continuous delivery pipeline kind of works is that we a bot and we deploy our code onto it using Chef. Then we run our test cases against that. And test cases succeed, the code gets pushed to the environment. It was a desired environment. So keep both things kind of independent. Otherwise, if there's dependencies, then they have to be rolled out together. And we don't want to do that.
Okay. Great. That was helpful. So the next question is, was the previous heavyweight framework also based on Selenium/WebDriver, for example, pure Java test?
It was based off pure Java Selenium WebDriver. The only problem was there was a lot of code and functionality built on top of it. So it wasn't the technology that it was using that was flawed. It was just the whole work and it's scaling to all the developers. So it wasn't a technology problem of what technology to use. It was the architecting of the framework and architecting towards the customers or, the people that are going to use it, which didn't go very well.
Okay. Do you launch your tests manually, or do you have a build manager that runs the tests for you automatically? If it's automatically, how often do you run your tests?
Tests are run in part of our CD pipeline. So tests are run on automatically as part of the build when it is supposed to promote to the next environment. At a precursor, it'll run the test, and if there's no manual kicking off of tests at all. The whole point of CD, continuous delivery, is that there's no manual intervention. Everything should just kind of on its own, kind of like like when you see a car being made on an assembly line by the robots, it just happens. There's no human that presses a button that triggers a robot to do something. Okay.
So this is really, I think, kind of just get a little bit more of your feedback as you transitioned. Someone asked, as you are transitioning from manual testing to a CD model, at the beginning, is it better to get all the test scripting for existing regression scenarios completed first before switching to this model, or what do you recommend from your experience?
Good question. Very good question, actually. Yeah, so So there's two ways to approach this. You can not write the existing test because you're kind of pushing the code anyways without telling that. Yeah, sometimes you're testing it manually, but if there's not a test case written for it, you're pushing the code without testing it anyways. So you could go ahead without reading the test and go to the CD model, but that'll put you at risk of when that feature breaks, you won't know. So the safer bet is to route all the test cases before moving to the CD model, since test cases are the only thing that's preventing an outage, meaning that if a feature is broken and all the test cases pass, the code will get pushed to the next stage. That's the problem. So the only defense you have in is the end-to-end or functional testing. So if you have a lot of users and a lot of revenue, depending on your website, and a lot of if an outage will really impact the company, I recommend writing out all the test cases for the regressions before moving out all the possible regressions, cases for all the possible regressions before moving to the model. Because the model, your code can get pushed to production without mention and without you knowing.
Oh, thank you. I'm going to combine two questions here. One was, are you testing in production, or was there a separate staging test environment? You might have just kind of covered that. And then along with that is, how long did it take you to set up and implement this stack?
So the way we do our pushes is we have a particular component. Let's take, for example, mail options, which is the settings inside of Yahoo Mail. That is one product. So what first is all the functional tests for product will run against some type of test server with the new code put on. And if that passes, it gets put onto the QA environment, and then our integration tests run, which is tests from all different repos against the set of packages on the QA environment. And if that passes, it'll promote that to pilot. It is all internal users, meaning me, my coworkers, my manager, even our CEO, and they all get that version of Yahoo Mail. And then if things look good for some period of time, automatically it'll get pushed to one. Well, I say 1% users, but it's actually much, much less than that. But 1% of our users, and then we'll give the metrics. And if nothing goes wrong with the metrics, then automatically it'll get pushed to 100% of production users. So that's how we do our pushing. And what was the second question, Christina?
How
long did it take you to achieve this tech stack?
How long did it take you to execute on this test suite?
So, for about 1 month, I kind of just around and looked at all the existing technologies and used them to see if any of them would meet our need. And I started experimenting with various types of test runners and search libraries and all other things. And the tech that we're using was the best, but it took me about to get the whole stack, just get it into the build environment and get an existing, basically migrating the existing amount of tests to the existing to the new framework. So it took me 3-4 months.
What coverage percentage did you shoot for?
Okay, code coverage, interesting question. So we shoot for 70, but the way we do, it's not all of our products have 70% since we deal with a lot of legacy. For instance, our mail storm application, or our main mail application, it basically inherited. Like, we've never started over with a new code base. Like, it's the same base from a lot of years, like I would say 10 years ago, and we just keep iterating that. So there's products like that, achieving 70% code coverage would not make any sense because a lot of the code is kind of sometimes dead code or unused code or uncode. So what we do is for new products, we try to do 70%. And the way we do this is when we create a new product of some sort, we check in some type of JavaScript file and then achieve 70% code coverage on that. And then what our build does is if the code coverage, if a commit code coverage, it'll still build. So basically, if you start with a certain number of code coverage, you maintain that throughout or better throughout the product time. So shoot for around 70. That's what I believe our company wants us to do.
So we have a lot of questions all around this premise of training your developers to write their own code. There's just a lot of questions about any issues with that. Someone wrote, what about the old school belief that there could be blind spots in testing, or if somebody's writing their own code, where is sort of the double check on that? So just kind of that transition of having them write code, any problems that you had there, how long it took you actually to train them to do that, and any blind spots that you've seen or any issues.
Yeah, so the training is an ongoing process. There's some developers that are very, very good at writing tests. There's developers that are not so good at writing tests. So what happens is like the ones that are very good at writing tests, they'll complete the feature they're working on and complete the functional testing, then ship. But the ones that are still catching on to the functional testing side, they'll finish the feature, but when it comes to the functional testing, once their manager says, hey, we need tests for this before ship, they have to spend time learning it. So therefore, it's a kind of a corporate culture change where your core has to support the meaning of writing functional tests and support the learning of functional tests and people to teach as well. So the change is ongoing, but it took about 3 months, and then develop a writing test. Along with the beliefs of writing your test, I don't think that's just a good because they know exactly what the of your product might be. They don't have any context of your product. If you write functional tests in such situations that it encounters or it tests all entry points and all different data sets, that you're basically covered.
And somebody
again, Christina, sorry, that was a little.
no problem. And somebody actually asked as well, along with that, are the developers kind of overloaded? Automating the functional test scripts, including the unit test scripts. So people are just kind of curious to the shift of developers writing their test scripts and just concerned about any potential blind spots if they're writing their own test scripts was the question.
So the overloaded, I wouldn't say overloaded. Writing tests should be painful. Writing tests should be enjoyable, like I said. Writing tests in this American Ruby way is very enjoyable. And why our developers are not overwhelmed by it is that once you get a solid step library and page object library, then you can reuse these things and leverage them. So basically, the first 3-4 months of me setting up the framework was also about setting up a good library of things so that developers, when it came to writing tests, that they could just concentrate on writing the test and not others with getting into the mail app and getting it into a testable environment and everything. As blind spots, so I kind of missed out on this on my presentation a little bit, but like I said, our code gets pushed to our servers, which we hit many times a day, but eventually it gets pushed to all the internal users, meaning the email that I'm using at work is the build. And since I have thousands of people inside our company using this for the email, and we also have a bug tracking link at the bottom, we can rely on our company essentially doing our, like, in a sense, while using the mail. And when something is broken, we hear about it immediately because our or whoever, our executive could not send a mail because we broke it. So that's how we avoid all the blind spots, is that we release to our internal users. We use this for a good amount of day. Then if things are okay, meaning that the 100,000 or whatever emails that got sent out in our company and read and sent and everything's fine, and then we're okay to go on to the next step. So yeah, that avoids blind spots, but you make sure your tasks cover every, scenario, or if you could, every scenario, and move on.
Okay. I'm going to ask two more questions. We're coming up to the end of the hour. Somebody has asked this question a couple of times, so I just want to make sure to address it. How do you handle cross-browser testing in the CD model?
So when the tests get run inside the pipeline, it gets split into, each case gets split into 6, and the 6 for 3 browsers and 2 different languages. So that's how we do that. So it executes in Windows 7, Chrome, Firefox, and 10, every build. When we release to our internal users, everyone's using various browsers, and so if a problem, we hear it from there. But we're also trying to ramp up the number of browsers and OSs we test against. Just kind of achieved this, and we're just right now, but once the time comes, I'm going to flip more browsers on. I just don't want to add any more, test failures and instantly into the pipelines, because we finally got going.
Last question. We did have a couple people that were curious what the main decision was that influenced your move from Selenium WebDriver to Water.
I mean, Water WebDriver does convert into Selenium. It's just a wrapper that makes it easier to write things. Before I would write lines of Selenium WebDriver code, and it would be like 100 characters. Then the equivalent statement in Water WebDriver would be like 60 characters. So it's just about being more concise and descriptive with the selectors, where like I said, in WebDriver, there's a lot of find element by, whereas that concept is needed in Water WebDriver. You literally substitute Water WebDriver and Selenium WebDriver in the tech stack, and it's just about it more simpler and more concise. And also open source support around Water WebDriver. A lot of companies using it, a lot of people using it.
Fantastic. Neil, this was really great. Thank you very much for your time. And to the audience, we have so many questions we did not have a chance to get to. And I think we will ask Neil to address some of them in a Q&A, some of these additional questions we didn't have a chance to address here. So look for that in our blog post. I will actually send a link in the email along with the recording of today's session and with Neil's slides. Look for that within the next 48 hours or so. Anybody who has registered for this webinar will receive that. Thanks again, Neil, and thanks to everybody for joining us today.
All right, thank you.